Hi guys, I am Razvan and I lead the penetration testing team at Pentest-Tools. Today I'm going to show you how to use the full power of Pentest-Tools to perform a comprehensive penetration test for your clients, starting from recon, vulnerability assessment, manually confirming the vulnerabilities, and generating a report. We are going to show you how to do a black box assessment on a web application, starting from the hostname that is hosting the application. We have just created our workspace and we will start adding the assets. So the client said that this host is in scope and everything that resides on the respective server is also in scope. So we are going to do first a port scan. When doing penetration tests, we start with a full port TCP port scan, a full port range. This is how you do it. You have to select the custom option from the port scanner and to start the scan. Also, we do a UDP port scan, but only, let's say, a deep, which is top 1000 ports. What is important is to monitor the attack surface section on Pentest-Tools, because here you will see every port service protocol exposed, and you can start doing the penetration test based on this kind of exposed services. So let's see how it goes. What we know already, and we can, let's say, profit, is that the host is also serving two web applications. This is one of them, which runs on port 80. So I'm going also to add it as an asset. Okay. For web applications, we usually use the website scanner, which is a tool created in-house by Pentest-Tools. Website recon to see what kind of technologies are running behind the scenes. And also we can run URL fuzzer, which tries to find hidden files and folders. So let's run a few of them. Okay, we have started the website recon. Now we are going to start the light version of the website vulnerability scanner. For this demo, we are going to start only light versions of the scanners, but I'm going to show you the results of a full website scan. How does it look like? Of course, when we do a pen test, we try to also explore the web applications manually. Here it looks like a static web application. Here we have Wapalizer tool, which says what kind of JavaScript libraries are in use. So we have few, let's say, informational items here. What else? Here it's an image. If we open this image, another tab, here we can see that the application is also using an S3 bucket. So for this reason, we are going also to scan the web app with Cloud Scanner. Okay, let's do this. This was running on port 5013. So yeah, our scan also confirmed the fact that this port is open. So let's add it first as an asset. Okay. So this is our static. Let's say here static web app GraphQL, and this one was actually this application, which seems to be a medical record system. Okay, we can rename it. OpenMRS web app. The client says that the test should be done from black box perspective. So here the scope would be to assess whatever services are exposed and if there are any vulnerabilities which might lead eventually to compromising either the server or one of the users of the application. But we will, let's say, refrain on the black box perspective. Okay. What else? So we have here some issues already. The scanner said that the communication is not secure because, as you can see, the login is done on port 80. Okay. Let me run also for this web application a few tools. We start with website recon. Okay. We said that also Cloud Scanner would be good to be run because the web application is using an S3 bucket and there might be some misconfigurations, some cloud misconfigurations we will see. And let's run also light website scanner. So we choose here the light version. Okay. In parallel, when we do penetration testing, we use several other tools. One of the tool which is very common is called Burp Suite Pro. We are going also to fire it up. It will be very helpful when we are going to do manual validations of the issues. Okay. So this is how it looks like. Let's go here on proxy, open browser, and we are going to assess both applications. But first, let's start with this GraphQL. Of course, this is a dummy instance of a web application, but probably with less functionality. But in real life, you will encounter this technology pretty often, actually. And there are several very common vulnerabilities affecting GraphQL, from introspection vulnerabilities to even SQL injection and command injection and many more. Okay. So let's see. Let's do this. Let's use a note-taking app to, let's say, monitor our progress. Because now we have two web applications and we have to make sure that we cover both of them. So from a recon perspective, we are dealing with these two web apps. Okay. And let's focus first on this one, which runs on port 5013. Okay, we know that it is a GraphQL app. Okay, and let's see what the scanner said. Okay, communication is not secure. This is not very important because the application is not presenting any login form. Okay, you don't have HTTP only flag on the cookie. It's not very important, again, because we are not dealing with sessions here with authenticated users. And also some missing security headers vulnerabilities, which might be taken into consideration. Of course, on a real web application, such things are important and we report them to our clients. But given the fact that this is just a static, like a presentation web app with no login and let's say no text fields, no input fields, probably these vulnerabilities might get ignored. So we are not going to report them. The cloud scanner, let's see what kind of issues it found. Okay, so we have here a bucket and it says that it's publicly readable. Okay, that's interesting. If we try to open it, okay, we can see here that there are some files which can be listed. This one looks interesting. It looks like a backup file. We are going to download it and see what is inside. Okay, here we have the logo. It's not very important. Also a JavaScript file here. But this one is really interesting. So for this reason, let's put it here. So like potential vulnerabilities for this web app. We have a publicly readable AWS S3 bucket. Okay. To take into account. And that's it. But yeah, maybe we are lucky and it's something very interesting there. So to get the file, let's put it here. Okay, we have downloaded it. I will use a terminal to get it, and I will show you afterwards. Just a second. I have downloaded the file and put it here in this folder. So we have a backup file. Let's check its type. Okay, it looks like it's an archive. So we can remove the .backup extension. Okay, and afterwards we can unzip it. Good. So let's see what is inside each file. Okay, so we have a readme.txt file which contains actually some clear text credentials. We can create some word lists with these credentials to try to run a Password Auditor tool, which will confirm if these credentials are valid or not. For this, let's go here under Settings, Word Lists. Okay, and let's name this OpenMRS users, which are this one and this one. Okay. And for passwords, OpenMRS passwords. Okay, and this one. Maybe they are valid credentials for the second web application actually. So this one would be, let's say we can of course test it manually. Open MRS and open MRS 1, 2, 3. Okay, it's not a valid one, but let's check also the second one. This one seems to be valid. Let me not go there yet. I will also run Password Auditor using these word lists to see if it works. So let's choose this login page as an asset, and we are going to run Password Auditor only on HTTP service, and we are going to use OpenMRS users and OpenMRS passwords as word lists. Okay, let's see if it works. Okay. So while this is running, let's put here a few other vulnerabilities just to have them in mind for the reporting part. So for this web application, okay, somehow this scanner didn't find them as valid, but we have tested them manually, so we have the proof that they are actually working. Let me check something. So okay, this is the page actually. Let me try also against this target. It shouldn't make any much difference, but let's try. Okay. And users, passwords, okay. Start again. Sorry. This one should be declared as an asset first. So we are going to restart it, but on this URL. Users, passwords, okay. Let's see if it works. Okay, so here we have noted publicly readable AWS S3 buckets found. What else? A sensitive backup file exposure, and because this file contains actually real credentials, clear test credentials. Okay, so for some reason it doesn't show you that these credentials are working. I am assuming it is because the login is done, let's say, in 2 steps. First you have to insert the username and afterwards the password. So this might be the reason, but anyways, we have manually proven that the credentials are valid. Okay. Let me also show you some results of a full website scanner against the same targets. So I will move here, and here you can see that the website scanner, this one is a deeper option. It took a while, 40 something minutes, and it performed 86 tests. It's much more comprehensive than the light version, of course. This one actually identified few interesting issues, and we are going to pick up some of them to manually validate them, and to put them in the report afterwards. So here you can see that the scanner identified the critical SQL injection vulnerability, which affects actually this GraphQL. Okay, so let's go and try to replicate this issue and to manually validate it using Burp Suite. So we have this app here, and let's go and do like this. Let me make this bigger. Okay. The endpoint is /GraphQL. So we are putting here /GraphQL. Okay. The method actually is a post method. So we are going to change the request method to a post request. And we have to provide, of course, this query. So here is the original request response. Let's run this first. Also make sure that the content type is application/JSON actually here. Otherwise, it gives you this bad request response. Okay, so this is like the positive request. And now the scanner modified the request and appended here a colon, an apostrophe. And it triggered this SQLi 3 error message, which gives you the sense that here might be an SQL injection vulnerability. We can, of course, use other payloads to prove the vulnerability. And for this reason, I have prepared already 2 queries, which will list actually the tables. So this request lists the audits table. I mean, it lists all the tables, and you can see that in backend there is only one table called audits, and this is also the let's say SQL definition of the respective table. So we can prove this way to our client that the vulnerability exists. It's a valid SQL injection vulnerability. So we are going to do this. We are going to make a clone of this vulnerability to have it editable and to finally put it in the report. So I'm going to the findings section and choose here critical. Okay. I will clone this finding. As you can see, a copy is created, and here it says manually edit. So you can either add your own findings, either written from scratch or using templates, or you can simply clone a vulnerability which is found by our scanners. We go here and we will say something like this. Okay, so how to reproduce? identify the vulnerable parameter within the GraphQL query as filter. Filter is the vulnerable parameter. Copy. Okay. Inject the following payload, or simply send the below body request and notice its response. Okay, and we are going to copy this, and you can make it also a code block. Okay, and let's make also a screenshot. Okay, capture area. We are going to capture this. Okay, here is the payload. And here is the result. Okay, let me copy this and I will paste it here in how to reproduce section. Okay, here if you want, you can leave this table as it is, or you can, I don't know, delete it or take only the section that you need. What I'm going to do is to take only the evidence part. So let's do like this. Vulnerable URL is this one. Okay. Sorry. So let's take this. Okay, and the rest of the table will be deleted. So I'm not interested in this one. Okay. Now it depends. Is it critical? Is not critical? It might be, of course, assessed by you during the penetration test. What it really matters is the business context, of course. Is this SQL injection vulnerability can you use it to exploit and to dump all the database, or to list all the tables, or even to get remote code execution? In our case, it's being just a static web app. You can list the tables. I cannot say that it is so critical, so I will lower it maybe to high or even medium, but let's mark it as high. Okay. Here you have also some references, and I think this is pretty much about it. Let me mark these issues with an R from report, just to be easier to follow what we want to report or not. Of course, it's not mandatory to do that, because you will see all of them with manually added value in the list of findings, but just let it here to be marked with R. Okay, so we have our first vulnerability. Also, the scanner identified an OS command injection. This might be even more interesting than the SQL injection. So let's try to prove it. But let me go to the scan and to take from there the proof generated by the scanner, the website scanner. Okay, so the vulnerable asset is the same. It's also the /GraphQL, but with another payload. So here we have an SQL injection. Let's send this to repeater and get this query. You can see this is the original one. It seems that the arg parameter is the vulnerable one, and here is let's say a custom command which runs and basically proves the fact that the application is vulnerable to OS command injection. So let me try to get this query from here. Okay. So what it does actually is that it echoes this string, and then it does some reversing and also transform the lower cases into upper cases. And that's why you see here PTT with capital, with upper cases, and followed by these numbers. But of course, it's much more elegant to have another type of command, which does actually, I don't know, a list of files, or it reads some files. So let's try to do that. To delete these things and maybe to run here an ls. Okay. So here you can see the file list actually. We can also find the path. Sorry, I have broken something. Yeah. So pwd. Okay, so we are in this folder actually. We can also find the user or the ID of the user. So the user which runs actually this application is called dvga. We can of course read maybe the etc passvd file. Okay, so I think this is very good as a proof that here we have an OS command injection. Let me do also a screenshot here. Okay, so but first we have to clone the finding to have it manually there. So let's go to findings, to critical. It was a critical one, OS command injection. Let's clone it. And eventually this might lead also to remote code execution, but it depends a lot on the type of tools that are installed on the respective server. You can use netcat, or you can try to see if netcat actually is running on the server. You can do whatever you want. We will leave it as it is. We will mark it as high risk. And how to reproduce. Okay. We will say something like this. Send below GraphQL query to the server and notice its response. Okay. Okay, here we have also references. And for evidence, we are going to put the screenshot. So let's do this, capture area, and yeah, make sure that you have the vulnerable parameter in the screenshot, and also the response is clear. So let's highlight this. This is the injected command, and of course on the right side you can see the output. Okay, let me copy and paste the proof here. Okay, so we have found two nice vulnerabilities. Actually, the website scanner identified it, so it made our life very easy. We just used Burp Suite to confirm the issues are actually valid. What else? There are, as I said, there might be several GraphQL vulnerabilities. Let me go and check the scan itself. So here is a GraphQL circular reference, field duplication, alias overloading. Let's try this one. We are not going to report everything during this demo, but of course you now have a picture of how to use Pentest-Tools basically to do such assessments. So okay, let's try to use this query to see what happens. So this one is an OS command injection vulnerability. Okay, and with this query, so what means is that I'm trying to query for an invalid attribute, but due to a misconfiguration, the server tries to correct me, tries to help me, and offer this kind of suggestions. So, hey guys, here you have a typo. Maybe you don't want to ask for directive, but for directives. So this suggestion helps attackers basically to identify the entire structure of the web application, which is using the GraphQL technology. So, okay, let's quickly submit this issue also. So the process is the same. Let's see if we have also a template for this. So as I said, you can submit issues, or you can create them manually, or you can use already existing templates. Let me try to see if there is one. So I'm going here to use template, and I'm trying to find, yes, GraphQL field suggestion enable. So I can use the template. Here, usually I put it on verified after I do a full review of the issue, but let's mark it as verified from the beginning now. Okay, the affected asset is this one, the /GraphQL. Okay, how to reproduce, send the following request to the server and notice its response. And we will use again a code block. Okay, and as evidence, we take a screenshot. Capture area. Okay, the payload, we highlight payload and response. So the payload was this directive, And this is the problem. The fact that the server is trying to suggest us what is the correct parameter here, the correct attribute. Okay. And this is a very good finding. I would mark it as a low or as an info. It's not quite medium or high. Let's mark it as a low. Another interesting type of vulnerability affecting GraphQL is the introspection, when the introspection is enabled. And let's see how it looks like. So, introspection. Okay, the website scanner identified this issue already, but we are going to manually validate it also. So for this reason, let's go and check the scan and see how the request response looked like. Let me type here introspection. Okay, so this is the request. Okay, let's use it. So this was the suggestion vulnerability, and now we are going to use to try to validate the introspection. Okay, paste. Okay, this one seems pretty simple. It's not very large output here, but we can use also an introspection query to find the entire schema. And I have prepared it here. Okay, let's run it. Okay, so here you can see the entire GraphQL schema. What you can do with this, you can use tools like Voyager to actually see visually, to see graphically the entire GraphQL schema. How to do that? You go here on Change Schema, click on Introspection, and here we will paste actually the response generated with this query. So let's paste everything, and we have to remove this header. So you have to keep only the JSON part. Okay. And if you click on display, basically you will see here the entire GraphQL schema of the application. This is useful for attackers because you better understand the entire application, and of course you can try to focus on specific functionalities of the application. For this demo, we're going just to report the fact that introspection is enabled, and we will use the payload you have seen. So let me report this issue also using a template. Let's see if the template exists. Okay, GraphQL introspection enabled. The vulnerable application is this one, /GraphQL. Issue the following request, or let's say send the following request to the server. And notice its output. Okay, this is the query. Use this website, okay, to visually display the GraphQL schema. And we can take 2 screenshots. We can have a screenshot with a request response, and 1 screenshot from the Voyager tool. Okay. And the second one here, with Voyager. Okay, copy and put it here. So if we filter the findings using the source manually edit, we can see already a bunch of vulnerabilities which we are going to use it to generate the report in the end. Let me remove this tag because it's not important. Okay. So let's summarize a little bit. We have this GraphQL application. We showed you how to manually validate a few issues, a few important issues actually, like an SQL manipulation and an SQL injection. Okay, we also, the same app, we proved that it exposes some readable AWS S3 buckets, which actually contained some sensitive credentials, some sensitive text files. Okay, let's edit this issue. So it's a publicly readable AWS S3 bucket. Okay. This is the proof, and actually the scanner says that you can use also this command in a terminal to see if the bucket is readable. We can do that also. Let's run this command. For this, you have to have AWS CLI already configured, and as you can see, yes, the OpenMRS bucket is readable because we can list all the files in there. Okay. Here again, I have to make sure the references are okay, and you can mark it as verified. The web application is this one, okay, so it's not /GraphQL, but on the root, and yeah, we are good with this finding. Okay, coming back, we noted here that we found some sensitive files, right? So sensitive backup file exposure. Let's see if we have a template about this issue, let's search for something like, I don't know, sensitive exposure of sensitive or sensitive files found, actually, yes. So you can use this template. I would say it's a high risk one because we have valid credentials, and we will check afterwards where this might lead. I mean, what is this OpenMRS application used for? It seems it's a medical record system, so it might contain, of course, medical information like personal identification information, PII, or even sensitive medical records. And based on that, of course, you can assess the issue as high risk or critical risk. Okay, so sensitive files found. Where we have found these files, we found them actually on an S3 bucket, but which is related to this application, which runs on port 5013. Okay. Evidence, let's put actually this as a proof. So, okay. Let's do a quick screenshot. Capture area. Okay. And yeah, you can highlight them, but it's not necessarily, because the screenshot is pretty explanatory, self-explanatory. Okay, and how we did that? Actually, we have listed the content of the OpenMRS S3 bucket. Okay, and download the backup file. Okay. So we have also this issue submitted, reported. Sensitive files found containing clear text, valid credentials. Okay. Nice. We also logged into the web app. So let's do that again. If we remember correctly, actually the admin credentials were the valid ones. Again, the assessment was to be done from black box perspective. So as an external user which doesn't have any knowledge about the web application internals, and tries to see if there are any misconfigurations on the server or on any other exposed service, which might lead actually to compromising the web application, the target web application. Let me try also to use Burp to do the login and see. So here is the credential, the password. Okay. Let me make the screen bigger. Okay, so yeah, we can see here actually there are some data. Of course, it's a dummy data, but in real life might be very sensitive, very dangerous, and yeah, of course you have to make sure that such information is very well protected. It's encrypted. It doesn't is not exposed to any unauthorized users. So yeah, imagine that this information is pretty sensitive, and you might have, let's say, a glimpse of what an readable S3 bucket might lead to actually. Okay, so we can also have another screenshot. Let's say we can assess, of course, these credentials. They are not quite weak. You cannot say there are some default credentials. This one looks like a pretty strong password actually. But the fact that it is accessible by anybody actually, this is an issue, of course. This is a security vulnerability. Okay, let's also check. So we said that we are going to take also a screenshot of this web app just to prove that the credentials were working. So I'm going to take another screenshot. Of course, if such information would be in fact sensitive, when we do screenshots, we blur things. So let's see. I mean, let's consider these pieces of information that they are critical. Of course, this is a dummy first last name, but of course this should be also blurred, and so on and so forth. So for demo purposes, we leave it as it is, and let's put it here on this issue on sensitive files found containing clear text valid credentials. This is the content, how to reproduce. Okay, evidence, and credentials are valid, and they might be used to log into the application. And we can put here this screenshot as a proof. Okay. Good. So it seems that, of course, the website scanner did a very good job identifying a lot of issues. We have manually validated a few of them. This application is running on port 80, so of course there is another vulnerability about this. So let's use another template. I like very much the fact that Pentest-Tools comes with these templates. Of course, you can add your own templates. You can do whatever you want. Of course, when a vulnerability tends to repeat during your penetration tests, it's very good to have a template created by yourself that you can use anytime, very easy. So communication is not secure. Let's find this. Yeah, communication is not secure. This one. Okay. You can change it into, I don't know, let's say login page exposed via HTTP, clear text. HTTP. And the affected application is this one. Okay. Simply access the web application on a browser. And as a proof, so this one is already logged in, but I want to delete the session. Just a second. Okay, so here we can see another vulnerability that the JSessionID cookie is missing the secure flag. So let's note it down and do a quick screenshot. And afterwards, we will continue with this issue. So let me do like this. Okay. JSession, show advanced. Okay. Shutter. Okay, let's keep this in mind. But I wanted to delete now this. Okay, and put this URL here. So access on a browser, and as evidence here it says not secure. Let's do a quick screenshot. Okay, it's important to have in a screenshot the entire URL. Okay, and we show here not secure. And yeah, so let's copy this, put it here. Here is the recommendation, and let's let's leave it as medium risk. Okay, and one more finding, and then we will move to the reporting part. It was related to the session cookie because it was missing the secure flag. So let's see how it goes. So here is the JSessionID. Okay. Let's report this issue. Secure flag. So it's an insecure cookie setting. Here, missing the secure flag. Okay. Okay, here we have the reference. I will put the screenshot as an evidence. It's on here. It should be. No, not anymore. Okay, I will take another screenshot. So this one. Okay. Let's blur again the sensitive information. It's not relevant to the vulnerability itself, because here in this area is actually what we are interested in. Okay, and we highlight also the name of the cookie, JSessionID. And that's it. So we copy the screenshot, and we say while browsing the application, check the session cookie flags. Notice the secure flag is not set. Secure flag on, let's put the name of the session cookie, JSessionID, session cookie. Okay. Good. And this one was the application. Okay. So we have now a bunch of various vulnerabilities identified for both applications, actually. Just to sum up things, we have started with a port scan. Then we did vulnerability scans, and then we have manually validate issues. One more thing, maybe it might be actually very interesting. As I said, it's very important to go here under attack surface view and check what other, let's say, potential attack vectors or potential entry points might remain exposed. So what we can see here is that on port 22 actually is running an SSH service. What about we try to actually test if these credentials are working? But let me do also something else as a quick thing. So I'm going actually to run again Password Auditor using the discovered credentials, but on port 22 on SSH service. So let's do this. We go here, we select this asset, tool, Password Auditor, and we are instructing the scanner to go on port 22. We can also instruct it to go and check the SSH service here, and we have OpenMRS users, OpenMRS passwords. Maybe we are lucky, who knows? Okay. It found the port. That was expected, of course. And now it will check if the users and passwords are actually valid. And in the meantime, we can also use another tool, which is called Sniper, to do an authenticated scan, because, you know, maybe we can authenticate. Let's first try. So if I'm going to do an SSH OpenMRS at this target, let's see if it works. Okay, and the password is OpenMRS123. Okay, so actually it worked. So this scanner should have identified also. Let me try again. Dictionary, SSH. Okay. Okay, so we are lucky. The credentials are valid credentials, valid SSH credentials actually. So we were able to log in to the underlying server of the web application, which is very interesting, of course. And for this reason, we can write another web vulnerability. Let's say, I don't know, remote code execution maybe. Okay, so yeah, the password auditor finished, and it identified SSH weak password combination, OpenMRS123. Okay, let's feed the sniper tool with these credentials. So let's put this target. Sorry, here. So we scan the health point target on SSH port 22, username OpenMRS 123. Okay. And let's see how it goes. Okay. So it says artifacts were successfully extracted. That means the scan happened authenticated. It was successful. What we can see here, the tool was able to list all the users running on the respective server. We have here the OpenMRS user, the one that we used to actually authenticate via SSH. List of processes. Here we have also network graph. You can see here some IP addresses, how, let's say, the architecture looks like. Okay. Some information about the network configuration, what interfaces are open, some disk drives. I like very much this view. It's like having a Windows Explorer or I don't know, yeah, a file browser actually. And you can see the entire directory structure of the server. So you can navigate. You can go, for example, here on /etc passvd. Let's find it. Passvd. Okay, so you can see it here directly. So without being necessary to log in and type commands, the sniper tool does everything for you, and it helps you to see this very easy, very graphically. It's very, very nice. And here is also a command history. You can see all the commands that were run on the respective server. So that was cool. So the last vulnerability we report, let's call it remote code execution. Let's see if there is any template. It's not. We said that we are going to report a remote code execution, or we can try first actually to find maybe some default credentials or weak credentials. Okay, I am going to use this one because it's already pre-written. Default credentials in use. I will put there weak credentials in use. Okay. Weak SSH credentials in use might lead to remote code execution. Okay, here the target is not actually this one, but I will add the SSH service in a moment. We found that the target application service has been improperly configured. Default credentials are still valid. And we either put here the right credentials or not. It depends on you. Let's put it like this. Okay. Okay. Connect via SSH to the server using the leaked weak credentials. And as an evidence, we can either put this terminal window, or you can go and take a screenshot from the sniper tool. It's up to you. Okay, I will make a quick screenshot. Okay, so we have this. These are the references. Okay. Good. So let's add a new asset. Port 22 and so you cannot you cannot add as a point as 22, but what we can do is going here on the findings and set here the port 22. Okay. Good. So now we have, let's say we are happy with the results. We have found 9 issues. For a black box assessment, I think we did a pretty good job. Usually this process takes a couple of days, but for demo purposes, just to give you a glimpse on how to use Pentest-Tools to do such engagements, such black box assessments or even gray box assessments. I think it's enough. Now we are going to go and report these issues. For this matter, you have to create an engagement and to use a template or to create your own template. So what an engagement means, there are some information about the client, company, let's say OpenMRS, contract number if any, when you have contracted this client, and which were the time, what was the time frame of this engagement. And I'm usually put here setting the engagement name to web application penetration test dash the name of the client, just to be able to find it easy. Okay. In terms of templates, we have here a website penetration test template. You can, of course, do your own. You can use these tags basically to populate your own templates with information which is automatically extracted from these tags. Okay, so let's try to generate one and see how it looks like. What I do is go here under findings. So once I am happy with the results, and all the issues that I want to report are set to manually edit. Because why I'm doing this is because I want pretty much always to add my own proof, my own screenshots, my own evidence, maybe to modify a little bit the text generated by the website scanner or other tools. So I make sure that everything is set to manually edit. Let me close this. Okay, good. So I select all the findings I want to report, click here on generate report. We want to generate a docx file. We are using website penetration test template and this newly created engagement. Here you can group findings by targets or by vulnerability. I like to group them by vulnerability, but you can do anyway. And also you can check this box, include all targets in scope. It might happen that you have several assets in scope, several IP addresses, several hosts, and maybe not all of them expose, I don't know, services. It might be the case, or you haven't found any vulnerability actually to be reported on every asset. If you check this box, you will make sure that in the report will be present the entire scope, no matter you find vulnerability on a specific asset or not. Okay, we generate the report. You can click here on download the report, or you can go under report section. You see that it has been generated here. It will be automatically deleted after 30 days. Before that, of course, you can download it, and let's open it. This is in dark mode. Let me try to see how can we change it to not dark mode, to light mode. Not from here. Let me try to find this information separately. System settings appearance. Let's. Okay. Appearance. Okay. So thank you for the short break. Now we have here the Word document. What kind of modifications I usually do to this report? I like to have a header here containing the following type of table. So I put here usually these things. So in the middle, I say web application. Let's do some zoom here. Web application penetration test report. And the name of the client. Let's say OpenMRS in this case. Okay. The logo here and the date here. Okay. table design, table layout first, and table design to remove the lines, the borders. Okay. Next, here I usually specify if it was a black box or a gray box assessment. Here, of course, in our team there are several penetration testers, and we review the reports between us. So let's say this was reviewed by Razvan Ionesco's colleague. Okay. The version after the review, the version will increase, of course. It will be 1.1. And here I will update the table of contents. And yeah, of course, you fill in the details here with the name of your client, who contacted you, what was the role of the person, and the name of the company. Okay. Here you will see that the target is the host. So if you have several hosts, they will appear here, or several IP addresses. Okay. This is a graphical representation, a viewer representation of the findings and their criticality level. It shows you how many high risk, medium risk, and low risk issues were found. And afterwards you have a table. Actually, I like to build the table. So let me just quickly do this just to show you. So we have 9 issues. It means that I will need 10 rows and 4 columns. So I'm going here, 4 columns, 10 rows, and I'm choosing this format, let's say. Here we have the number, the finding, the affected asset, and the risk level. And I am using white. Okay. 4.1. There are 9 findings. Okay. And we know already there are 4 high, 1 medium, 4 low. So we can put here high 4 times, 1 medium, and 4 low. Okay. And we can copy them from here. So this is the affected asset of the first issue, which is an SQL injection. Okay, an OS command injection. Okay. And this one is the affected asset. Okay. This one is here. Login page exposed via clear text HTTP. Yeah, with with experience, this part will take very few minutes. So I like doing that because it offers you, let's say, a more clear overview of the issues, of the affected assets, and the risk level of each vulnerability identified. And this one is the last one. Okay, and it's for this target. Okay. Good. Of course, you can format the table as you wish. You can modify things just to be, let's say, more beautiful, more visually appealing, let's say. Okay. Good. And let's have a look on each vulnerability. Here we have the list of findings with evidence, risk level, status. Here the status will be open for all identified vulnerabilities. When we do a retest, because in the next video you will see how we do a retest of these issues, we will change the status from open to fixed, not fixed, partially fixed, or accepted risk. Maybe the client will not invest time, effort into resolving every issue, and they might consider some of them to be just accepted risks. Okay, so this is how it looks like. If you want, you can keep also this classification table. It depends from client to client. Some of them, they don't need them. I usually remove this. And also this fact that the finding was manually validated, so it's not a false positive. I will not repeat the same piece of information on every vulnerability, but I have mentioned this, or I will mention this in the executive summary somewhere. Okay, so this is how it looks like. You can format the report as you want, and yeah, I'm trying to make this a little bit smaller, just to be on the same page. Okay, so yeah, I will not do this for the entire report, but now you have a grasp of what is the process when dealing with web application penetration tests, what kind of tools are we using, how we manually validate issues, and how we generate the report in the end. The report, of course, being the most important deliverable the client will notice. Okay, so here in the end, you can also have an addendum with a list of tools that you have used to detect these findings. I do not usually put this piece of information. What I'm doing though, when dealing with network penetration tests, here I like to place the attack surface view. So remember the attack surface that I have mentioned here. You can basically export this as CSV and paste it here basically in the addendum area. just to show you to the client that you have tried to identify all exposed services. So they will see basically what you have tested and what you have not covered maybe. Okay, so this was pretty much about it. I hope you enjoyed the process, and we will meet you guys in the next video when we do a retest after the client has been patched the vulnerabilities, of course, if they wanted to. We delivered the report to the client, and after a while they contacted us to do a retest. They claim that they have fixed every issue we have reported. And now I'm going to show you how we do step-by-step the retest, how we check manually each finding, and how we eventually generate the report. I have opened here the pentest report initially generated by us. I do a few tweaks, like writing here the fact that it is a retest report. Of course, change the date and modify the version. And for each finding, I'm going to walk you through the manual retest, and we will update the status of the finding. So we have added here a retest status column in this table. And for each finding, we have added a retest status section. We prefill this section with this, let's say, sentence: the security team performed the retest and concluded the issue. And now we will see if this issue has been fixed or not properly fixed, or it is partially fixed, or eventually the client might say, hey guys, I'm going to accept this risk, or I'm not going to fix this item right now because I depend on other third-party vendors and it might take a longer time. But you have to know that we deliver each pen test on a, let's say, 1 week, 2 weeks time frame. And with each pen test, we offer you a free session of retesting, so no worries. Good. Let's start. For this matter, we are going to fire up again Burp Suite. And copy the affected target. I'm going also to show you the windows right now. So we are going to add here the target. And based on the report, we know that the /GraphQL endpoint is actually the vulnerable one. So let's go there and access it. Okay, and now here we have our requests. We know that the GraphQL endpoint is accessible via a post request usually. So let's move this to the repeater and we change the request method. So we are good now. And let's check every item, every vulnerability. Luckily, we have added here the exact payload. So it will be pretty easy to copy and paste this payload. That's why we usually put such, let's say, descriptive sections, descriptive text, to be easy for us as testers and for the client, because they can, of course, fix the issues and do the retest by themselves before they announce us that everything was fixed. Okay, so first item is related to the SQL injection. Here was the payload, if you remember. And now we can see that the response is 400 bad request. That means the endpoint has been patched and that the vulnerability has been solved. Okay, let me do a quick screenshot here. Good, and I'm going to paste it here under retest status. Okay, just a second. So capture area. Okay, and we can simply copy and paste it here. So the security team performed a retest and concluded the issue has been properly fixed. Okay, of course you can enter more details if you want, but for the sake of the demo, we'll put only this piece of information. And we will update also, as I said, the status here. We marked it as fixed. And we will add it also here in the executive summary table. And we are going to do these things for each of the reported findings. Now, it might happen that the clients are interested in solving only high-risk items, and this is normal, or high risk and medium risk, and ignore the low-end info findings. So yeah, it depends on the reason they are doing the pen test is either for a compliance or it's a comprehensive pen test and they really need to know all the issues. But yeah, we ask them, hey guys, what you want to retest? Do you want a full retest or not? And they tell us, okay guys, I'm focusing only on high risk items, do not spend so much time on checking everything. But now let's say the case is that we test every finding. Okay, for OS command injection, the payload was this one. And again, the endpoint responds with 400 bad request. Let's do a quick screenshot again here. Copy it. Paste. Okay. Has been properly fixed. So the client did a good job on these two items so far. Okay, I will update the table afterwards. So let's move on to the next one. Okay, so if you remember last time we have found some clear text credentials on a public S3 bucket. In order to test this issue, I'm going to recheck if the bucket is still publicly available and if these files, if you remember, it was an archive, a backup archive, if that file is still downloadable. Okay. So not this one, but this one. Okay. Let's check if this bucket is still publicly accessible. And it appears that it is not anymore. So let's do also a quick screenshot here. You see, with one fix, you basically tackle several findings. Okay, so publicly readable AWS S3 bucket found. This is fixed now. Okay. Has been properly fixed. You know that usually clients fix something, but forget, for example, to change passwords. So we are going to double check if the passwords that have been leaked are also changed. It's okay, of course, that you cannot access anymore these backup files, But let's see if they have also implemented like a good practice and have changed also the passwords. Okay, we are going to recheck this login on the main web application actually. So let's go here, and I'm going to pick up the previously found credentials. So if you remember, the clear test credentials that have been leaked are these ones, OpenMRS and admin credentials. Let's check again if they are valid or not. Okay, the first pair, it wasn't valid either previously during the pen test. It's not valid now. That's good. Let's check also for admin. Okay, that's good. So the client also has changed the leaked credentials. This will matter for, let's see, which issue. Yeah, for login page exposure clear text HTTP. It was an issue related to the fact that we have found, let's say, potentially sensitive information. You know, remember the personal identifiable information. Okay, so let's move on. Let's move on to the next issues. Sensitive files found containing clear text valid credentials. We demonstrated, yeah. So you remember that we have been able to log in and found this sensitive information. Now we have proof that this issue is not valid anymore, so we can clearly mark it as fixed. Okay. Has been properly fixed. Good. So for this one, we take a screenshot from here, shutter, okay, we copy it and paste it here. Good. Also, those leaked credentials were valid also as SSH credentials. We have been able then to connect to the server and get remote code execution. Let's check if it is the case now or not. So we use the terminal. And the credential were related to the OpenMRS username. So SSH OpenMRS at, and this is the host. Okay, and they ask for the password. Let's check if it is OpenMRS123. Okay, so it's not. It means that the client has also changed this password. The retest, it's about validating what you have previously reported. It's not a full pen test. If the client asks for a full pen test, it will be quoted differently and the effort will be estimated differently. Of course, you can run a new session of password brute forcing here or check other ways to get in. But during the retest, we check step by step every vulnerability we have previously reported. So for this reason, we can conclude that this issue has been properly fixed. I'm going to take also a screenshot. Okay, copy. We mark this as fixed. Good. Okay. So the client did a very good job fixing all high-risk issues, and that's a very nice thing. Let's check this one. So as you can see, they didn't apply here any HTTPS, so they haven't installed a certificate, they haven't configured this server properly. The issue is still valid. We are going to mark it as not fixed. The client might say, okay, it's an accepted risk, but in this case, such things shouldn't be acceptable. We will mark it as not fixed. And yeah, we mark it with a red color. So we put here the issue has not been fixed. And again, we will take a screenshot. For retests, it's very good to do new screenshots every time, so such that the client sees that you do the retest for real and you're not just reusing older screenshots. Okay. This one is fixed because we checked it previously. The S3 bucket cannot be accessed anymore. And let's move on to GraphQL now. We have a couple of issues still to be retested. Okay. We go back to the Burp Suite. Put here the payload. And as you can see, the issue is fixed. So the client fixed the entire /GraphQL endpoint configurations. Okay, we mark it also as fixed. Okay, and this one was related to the introspection being enabled. With this vulnerability, you can basically download all the configuration, all the methods, endpoints, and it's very important to have such an issue fixed in production environments. Also make sure that if for some business reasons you need this to be enabled, do not expose it for unauthenticated people. So make sure that these introspection requests are valid only for authenticated users. And also, if possible, make it available only for admin user roles, not regular users. Okay, let's take another screenshot here. Good. Copy. And paste. Issue has been properly fixed. Okay, this one, let's see if it is fixed or not. So the JSession ID had the secure flag missing. It appears that is the case. It is still the case. So this issue has not been fixed. Let's take a screenshot and mark the issue accordingly. Not fixed. Okay. Has not been fixed. Okay, so we went through all the issues. Remember number 9 and let's see which one were not fixed. So 9 and this one. 9 and 5. Okay. So let's go to the executive summary table. Number 9 is not fixed. And number 5. All the rest are, sorry. Copy, paste. Okay. Okay. We also go to Pentest-Tools to mark the issues there in the platform, such that, let's say, a new round of retest will occur, or another colleagues will be in charge with this pentest, so they will know what happened from one iteration to another iteration. So remember, login page exposed via clear text HTTP and the missing secure flag were the not fixed issues. So let's go here. We select only the manual reported issues. This one and this one are still open. Okay, we leave them as they are, so they are open. Now all the rest have been actually fixed, so we can change here the status to fixed. The client patched properly the issues. You can also add here a reason such that the colleague which will come will understand what happened. Okay. So next, what you can do, if you want, you can also regenerate this graph. We go to the client and ask them, hey guys, do you need a retest report containing all the issues together with their updated status, or you need a clear report containing only the remaining findings? So we can generate both of them, depends on the client what they need this, let's say, new deliverable for. If it is for internal purposes only, they don't care, they leave all the issues here. But if they want to send this report to a stakeholder or to somebody else, an external authority, for auditing purposes, you usually need a clearer report. Okay, so it's perfectly fine to mention hey, during the pen test, I know some high-risk issues have been fixed, so some high-risk issues have been found, but during the retest we concluded these have been properly addressed. Okay, so I think this is pretty much about it. Here we have, let's say, the updated overview of these issues. You see that most of them have been fixed, and the client choose not to fix these ones, but it's totally fine. You know, for example, for implementing SSL certificates, you might depend on some third-party vendors. Maybe you are not the owner of the server, maybe you need some approvals, so this might take more time. But I think we have managed to show you how to do a comprehensive pen test, how we use the full power of Pentest-Tools to help us in performing such complex penetration tests, and how we also manually validate issues and make sure that the clients are not receiving any false positives. And all the issues that you will find in the report are real vulnerabilities, issues that you can also prove by yourself, to test by yourself. And of course, under the how to reproduce section, you will always find step-by-step guide or exact payloads that you have to use in order to make sure that first the issue exists, and after you apply the patch, that the issue has been fixed. So thank you for the attention, and in case you have any other questions about our pen test process, feel free to drop us a message and we will be happy to answer. Thank you.